Okay, so we learn how we can control different things with our PWM generator and the Mosfet, yeah?
Yeah.
Now let's go back to the schematic. And if you remember on oscilloscope, what frequency it was?
It was from 700 to 400.
Yeah, something like that, right?
Yeah.
Now you know the audio spectrum. So with our ear, what frequency we can hear? From where to where?
From a point to another.
Yeah, from what frequency to what frequency?
I don't know.
You don't know?
No.
Okay, basically 20 hertz.
Okay.
Yeah?
Mm-hmm.
To 20 kilohertz.
Yeah, but here it depends of the age as well.
Yeah, but how do you know that?
Because you're deaf.
Okay, yeah, you know, when yeah, we have a problem. Always the oven. I can't hear the oven.
Yes.
Yeah. And many times, you know, the keys, Diana, you can't hear the beeping. No, I can't. Yeah, you're right. So getting older in age,
Yes, you
can't hear. Yeah, you can't hear the frequency. Yeah.
Yeah.
At the high frequency, you lose the ability to hear the high frequency.
Yeah, and you always told us like, when you're gonna be my age, it's gonna be the same. Don't worry.
I'm not that old. What do you mean? I'm not old at all.
Of course, you're not.
No, I'm not. I'm young. So our PWM generator, let's say somewhere here, right?
Mm-hmm.
Like you said, how much? Around 500 hertz, right?
Yeah.
So we should be able to hear this. You don't think?
Yeah, we just did.
What do you mean?
No, like.
You heard the buzzing from the.
You don't?
From the fan? No.
That's why I told you to put near to the microphone.
Oh, okay. Maybe I missed it.
Because it was like.
Okay, so how we can hear this frequency? 500 hertz, we should be able to hear it, right?
Yeah.
Now let's speak about speakers. Can we connect a speaker on our... somehow to connect a speaker? So a speaker is... That's a speaker, okay? You pay attention?
Yeah.
Yeah, okay. So you have the wire, yeah, you have one wire. Then you have a coil, which is a resistor, right?
Mm-hmm.
Then you have the other wire. And that's the speaker symbol.
Mm-hmm.
Usually speakers, they are coming on 4 ohms or 8 ohms.
Only.
So, yeah. So the resistance is from 4 ohms to 8 ohms. That's the speaker.
Mm-hmm.
Okay?
Mm-hmm.
The headphones, like our small speakers, they are coming probably from 8 ohms up to like 250 ohms. You have headphones to have 250 ohms headphones. You remember?
Which one was it?
The DT...
990.
Yeah. 250 ohms.
Yeah.
Okay?
Mm-hmm.
Just to understand what kind of resistance you have.
Mm-hmm.
Okay? So what is inside here, it's a coil around one magnet.
Okay.
Yeah? When you apply current to the coil is moving a membrane.
Mm-hmm.
Okay, just to understand, let's leave this on one side. That's a speaker. So you have the coil, you can see the wires of the coil there.
Mm-hmm.
This.
Yeah.
Okay? And it will make the membrane moving. Because the coil, it will create magnetic field, and then you have a magnet here.
Mm-hmm.
Yeah? So what is the resistance on this one? Check here. Yeah, check there. Like 8 ohms, right?
Yeah.
Yeah. Now coming with the power supply, because you have low resistance, you know what I mean? This will be high current.
Yeah. So
you will
this is
burn the
plus?
speaker.
Oh,
You're coming with 12 volts on a 8 ohms resistor.
yeah.
Yeah. So what we can do, we can lower the voltage or we can lower the current. So I lower the voltage. Try to connect it, but just for a short period of time. Just touch it.
Yeah.
You touch it.
Oh, it's moving.
Yeah. Try now. Maybe you can see it better. Yeah.
Mhm.
And on the other way,
What do you mean on the other way?
just change plus or minus. It will create different magnetic field on the opposite direction, right? And you can see the membrane is going down.
Down. Yes.
Yeah. So that's how the speakers are working. So how we can add a speaker on our schematic? This is our schematic. How we can add a speaker here?
Wait, first we need to lower the voltage because that's 12 volts. You cannot connect to that
Yeah.
straight away.
Yeah. You're right. You cannot connect the speaker here.
Straight, yes.
Because the speaker, it will get burned.
Yeah.
We cannot do this.
No.
No. So how we are connecting the speaker?
Wait, you connected between the gate and the source?
No, because even here we have like switching, like from 0 to 12, you remember? The signal on our gate it is like that.
Yeah.
And on our drain, it's higher. Yeah?
Mm-hmm.
So how we can connect the speaker? What component, yeah, we can use?
We need to add something
Yeah, like what?
to limit the voltage.
Yeah, but you limit the power, and I'm not happy with that. What about a component? You know any component which is letting to pass the switching but not the voltage? You know any electronic component which we spoke about this and I said, look, this it will pass the AC but not the DC. You remember?
Yeah.
What components? What electronic components you know can pass the AC but not the DC? We learn about this component.
I know.
It's not some secret component.
I'm thinking. We learn about. Wait. Diode?
No, the diode will pass only in one direction.
One direction.
Yeah.
No, it's not a diode.
It's not.
Capacitor?
Now you are taking every component?
Yes.
Yeah. Yeah, capacitor.
Capacitor.
We spoke about the capacitor.
Capacitor.
And I said, you know what? It will not pass the DC, but it will pass the AC. We don't have AC here. We have PWM, but it's about the same thing. I mean, it's not the same thing. It's going to zero. Zero and max. Zero and max. So what do you think? We can use a capacitor?
You ask me?
Yeah.
You are the teacher.
Yeah, but I'm trying to make your brain like, you know, like the wheel spinning inside of your brain.
Yes, but...
Okay, we can. How?
How? So...
Of course, has to be on the serial mode with the speaker, right?
Yes.
To stop the DC.
Yes.
Right?
Mm-hmm.
So I will say one end to the ground.
Okay.
And the other end, a capacitor.
Yeah.
With the plus on this side, obviously, because on this side it's the ground, right?
Yeah.
Okay. And from where?
From the drain.
From the drain, yeah?
Yes.
Okay. And you have no current flow because you don't have, you have only ground here.
Yes.
So will be no current flow. You understand your problem? You have to create a current flow. You have no current because
I know,
this is connected to ground. This is connected to ground.
Yes, and there's nothing on the other side.
Yeah.
I can see, but
So-
I'm thinking what is wrong there?
There's nothing wrong. You have to somehow to create a circuit.
Yes, and how do you create a
But you have to
circuit?
close this circuit. So you have sources connected to ground. You have drain, yeah? You have
Yeah.
somehow to connect it to plus.
Yes,
How?
you connect it to plus.
Yeah, but that it will be short. So when this it will switch, it will short the plus or minus. You understand? So this is like a switch. That's what it's doing, switching.
Yeah.
This is a switch. You want to switch the plus to ground?
No.
So,
So
what is the solution?
the solution is to put a diode
How a diode it will help you?
to the current go like this in one direction.
Yeah,
but
well,
it's not helping.
It's
Yeah,
you know.
it's not helping. No.
Yeah.
No.
I mean, very simple. How you can create a current flow? You can't just use because you will short the plus.
Yeah.
This it will switch the plus, right?
Mm-hmm.
What about a resistor? And you have a circuit. You have a current flow here.
Oh.
Electronic is simple. Don't try to overcomplicate it because I'm looking at you.
Yeah.
And you think too complicated things. Close the circuit. I need a resistor to limit the current, so I'm not shorting the plus, right?
Mm-hmm.
Yeah, and that's all.
Easy.
Okay, what resistor? You said it's easy. So what resistor we're using here?
But that's a good question.
You said it's easy. So what is the value of this resistor? Hmm? You said it's easy.
Mm-hmm.
Of course, this resistor, it will determine the current flowing, right?
Yeah.
So what resistor? If you are using like 1 ohm resistor, here you'll have like 2 amps. If you are using 100 ohms resistor, you'll have few milliamps. Right?
Yeah.
Okay, I have a better idea. Yeah?
Wait, we are not using the resistor or something?
Yeah, we are using the resistor.
Okay.
Yeah?
All right.
But what is this? This is a resistor?
No, that's a
This is a light bulb.
It's a
Okay.
light bulb.
Okay. Please, test with the multimeter.
Test what?
Test the light bulb. If it's not a resistor, doesn't mean it will not show you anything if you check the internal resistance, right?
Oh, don't say that, because it will show you. Look, it will show you it's...
So it is a resistor. You said it's not a resistor. So it is a resistor or not?
It is. But even a wire is a resistor.
It's not. It's a light bulb.
Yes.
It's a light bulb. It's not a resistor.
It's a light bulb.
Yeah.
But has a resistor inside.
Exactly. It's a light bulb but has a resistance. Yeah. Okay? Good. So what I'm thinking, check here what I'm thinking. I'm thinking to put here the light bulb to close the circuit. What do you think about that? Huh? It will work? So this, we're gonna have a current flow here, and we are coming with the speaker on the same way we came with the oscilloscope here on this point.
Mm-hmm.
Yeah? Let's try it. So first, solder the capacitor, and I think the easiest way is to solder the capacitor here. Then we are coming with 2 wires. What do you think?
Yeah, look, I soldered it. You put this there and it's soldered. There you go. I'm joking.
You're trying to
Yes, to make
get like shortcuts.
Yes.
It doesn't work like that.
make things easier. How do you can solder this?
Probably with solder wire.
Yeah, we can put a wire. Yeah.
No,
No.
with solder
Oh,
wire.
with solder
This
wire.
is solder wire.
No, because this one has a lot of.
No, doesn't have a lot of.
Yes, it does.
That's a cold solder. That's how it's called, a cold solder. Yeah, you see, it's not working.
What do you mean it's not working?
Look, it's a cold solder.
Oh shit.
You see? You see? First, be sure here, you know, the solder is getting soldered. Yeah.
Yeah.
And now you can solder. Better, but still I believe it's a cold.
No, it's
okay.
not.
Okay, okay. Now we need 2 wires from here, right? The capacitor in the serial mode, yeah.
Here.
Yeah, but you need flux.
Oh, you need flux. You need.
Okay. Good.
And this one here.
Yes. Okay.
I know, I'm good.
Not there, because if you solder there, this wire from behind, you lose it.
And now you'll say, oh, it's.
Yeah, you need solder wire. You need first to solder there, and after that, solder the wire. Good. Now let's bring the circuit here. Now solder back take out the fan, solder the light bulb.
Take out the fan. Solder the light bulb.
Yeah.
Okay.
And now the speaker. Connect the speaker.
Now connect the speaker. Wait. Can I see the schematic?
So the plus of the speaker is here with the capacitor, right?
Wait, but this is the minus of the capacitor.
Yeah.
And the minus of the capacitor, we're gonna.
Oh, okay. So you made it wrong. You soldered the capacitor wrong. So the minus of the capacitor is soldered to the speaker. And you solder the plus of the capacitor.
Because you told me that.
Yeah, but you should know. You have the schematic here.
Yes, but you told me that. It's not my fault.
I don't understand why you swap the capacitor when I can actually just swap the wires. But hey, you know.
Oh. Because I like to do more soldering.
Okay. And now connect the wires there.
So this one comes to the. Where's the schematic?
Here.
Wait, the plus is going to the. Which one is the plus? Of
Okay, this is the plus. This is the minus.
Okay.
You should know by now.
Oh wait, this is the plus. Yes, this is the plus coming to the drain. It's the drain here. here is the drain. It's going here.
Okay, and the other wire?
And the other wire goes to... where it goes to...
Where is going the other wire?
Oh, to the ground.
Okay.
Right here.
You need more solder.
I need... Oh, maybe the solution.
All good?
Yeah.
Now test it.
Alright, this is a plus here.
Yeah.
And that's the minus.
Let me take the speaker from here.
Going here.
And the light bulb.
Yeah.
Yeah. So you understand?
You can hear it?
Yeah, I can.
You can
Yeah,
hear it?
Yeah.
Yeah?
Yeah.
Yeah. Look at this. That's funny.
So you understand what kind of signal you have there?
Yeah.
Okay. Now, let's try something else. I want to check the signal on the gate.
The signal on the gate.
Yeah.
Okay.
So what I want to see the difference. Yeah.
Mm-hmm.
So I want this. Yeah. You pay attention.
Mm-hmm.
I want to jump here and actually connect this to the gate. What do you think?
Go back to the schematic.
Okay.
So, from the capacitor, the plus of capacitor jump straight away to the gate.
Yeah.
That means this one to connect it there.
Yeah.
Huh. What happened?
What happened? What do you mean what happened?
What happened if you put it there?
Because I want to check to see what signal do we have on the gate. We should have same signal, right? We should have same frequency.
Yeah.
Yeah? Okay, let's see. Actually, I don't want to solder this wire. I want, yeah, this is the speaker wire, right?
Mm-hmm. Just
I
to
want
touch
to
it.
start this, yeah?
Yeah.
Okay. Bring some light on the light bulb. Okay. Now touch to the drain for short time, just to hear the drain there. So you can hear?
Yeah.
Okay, now touch to the gate. Touch it to the gate.
Oh, maybe you cannot hear it, but I can.
Really? When you touch,
Yeah.
you can hear?
Yes.
Yeah, touch it.
You cannot hear it.
It's very high, right?
It's very high, but it's not that loud.
Okay, adjust it. On the other way. Now I can hear it.
Yeah?
Yeah. So you see, it's just,
Yeah.
I don't think they can hear. Why is not loud? So if I check here, it's like that. No,
Yeah.
leave it. Leave that one.
Yeah.
If I check on the drain, yeah, why?
Louder.
Why? Because this is what is this video about. Why is louder on the drain and not on the gate?
Because the frequency on the drain is higher than the gate.
Frequency.
The frequency, the high frequency. No,
the frequency is created here on this.
Mm.
Why is louder on the drain but not on the gate? Let's go to the schematic to understand. Yeah.
Mm-hmm.
Why here is not louder but on the drain is louder?
I don't know.
You don't know?
No.
Because here you come with a low signal, and I show you on the, but you didn't pay attention on the oscilloscope, and the signal here
Oh, it was higher.
is like that.
Yeah.
Because of the amplification. You understand?
Mm-hmm.
So this transistor is not only switching, it's amplifying the input signal.
Yeah.
So you come with a weak signal on the gate or the base, and you get the signal from here amplified. So you understand?
Uh-huh.
This is our audio amplifier.
Oh.
So if I take the gate,
Mm-hmm.
and I come with an audio signal, the audio signal on the drain will be amplified.
That's cool.
So this is actually acting the Mosfet as an audio amplifier. It's a basic audio amplifier,
Mm-hmm.
and actually they are separated by class, class A, B, C, D,
Yeah.
So this is a basic one, but it's still an audio amplifier.
Okay.
I mean, it's a poor one as a output power, meaning,
Mm-hmm.
but it's still an audio amplifier. So this is the configuration of an audio amplifier.
Oh, that's nice. So that means when my headphone doesn't work, like it has like there's no that loud. That means that one is not working properly.
On real life, you'll not find audio amplifiers like built like this.
Oh.
Yeah.
So they are building different.
Yeah. So this is not very efficient. It's not giving you a lot of output power. I mean, just check here. To have this kind of sound, you have to have a light bulb losing power. So it's far away to be efficient.
Yeah.
You understand?
Mm-hmm.
But just, I just try to show you what amplification means.
Yeah.
Because till now we work with signals, but we didn't realize actually the transistor is amplifying the signal.
The signal.
You come with a weak poor signal,
Mm-hmm.
and you are ending up with a high signal. Remember I told you, if you replace the LED with a light bulb, it will not work. Because those transistors cannot carry that much current.
Yeah.
But just having this MOSFET, it's amplifying the signal.
Mm-hmm.
Cool?
Cool. Very cool.